Hey everybody, so we'll continue this review type of um videos where we discuss different type of questions from college algebra. Let's switch here to this mode here. Let's see, not sure why it's not working. Here it is. This deals with the rational functions. And so, as I mentioned in previous videos, here it's not teaching from scratch, and at the same time, it's not skipping everything, and it's not just like solving. So, I like to have a mix of review and teaching in these videos. So, if something is missing, you'll find it, but in the same time, if you have an idea about it, that's good. If not, then after the video, you want to try similar examples and see what's going on, so you have a better understanding to it, right? So that's kind of the idea. So some of these videos are longer than they should, but that's the point, because I don't want just to solve the problem and that's it. Uh, we want to understand what's going on and connect the concepts, because there will be other applications where you will start deciding properties of what's going on and based on what you look at, right? So if in the previous ones where we did polynomials, we didn't have any breaks, right? It's not, the graph doesn't jump from one place to another. There is no corner to it. But this one, it looks like you have this side, and there is a kind of a break there, and you have this other side of the function. So there is this vertical asymptote and there is this horizontal asymptote. So it's not that the other type of functions. And we understand now that as the function changes, the graph change, but there are some functions that stay, even though they change, they stay in the same shape. So for example, 1 over x and 1 over x plus 1, something like that, you will still stay as a rational function, and it will not maybe look like a straight line, for example, right? Or a square root of x and square root of x plus 1, it will still be having the shooting star shape. It will be affected. And we did that in transformations. So it's the same function, it just changed some way, and the transformations, we saw that. And we also saw the types of transformations. And if we get that to other videos, we'll talk about it. So let's deal with this one. The graph of this rational function, f, is shown below. Assume that all asymptotes and intercepts are shown and that the graph has no holes to it. And if a graph has a hole, for example, it's something like, let's say, it keeps going, let's say something like this. And if you haven't seen this before, when does a graph has, for example, a hole in it? It's, for example, x squared over x plus 1, x squared minus 1. Let's just say this is g of x. So this is not a simplified form, and if you factor it out, so as you see, the denominator is not defined at -1. So there is a vertical asymptote at -1. But if we do this anyway, and we simplify it, we get x minus 1. So this g of x is just x minus 1. So if you graph it, let's say even on some of these online tools or a graphing calculator, you may not see, or you may not do. When we graph this, we go to -1 there and up 1 over 1, and kind of it's a line. Then So it should look as a line. That's g of x. But remember, the original function does not have x as -1 in its domain. It's not there. So it's the function g of x is not defined at -1. So what happens is at x -1, it's not going to be defined. So there is a hole there, and maybe we can show it by cleaning this thing here. And let's change now, say for example, that. All right. So this is a case, if you haven't seen it, and they're saying here that there is no hole in the graph, because if it's printed and it's not showing, they just want clear that out. But if you haven't seen this type, this is the case where it happens. All right, so we'll clean this out. And it is a college algebra thing as well. So let's go ahead and talk about this one. And maybe we need to clean as well here, because we just put a clarification to what that means. Use the graph to complete the following. The first question A, find the vertical asymptote. So it's here, this x equal -1. And as it says, enter the equations using and stuff. So the equations, so we don't say the answer vertical asymptote is -1. This doesn't mean much for this because it's a line, and that's x equal -1. The horizontal asymptote it's here at y equal -2. And it looks like that's all. We have one of each. Find the x-intercept. So we talk about x-intercept. We've done algebra to find them. And this reinforces that if you're looking for x-intercept, you're trying to find where the graph intersects the x-axis. So it's -3, right? For the y-intercept, it's this value here. It's -6. And if there aren't any, you're going to select none, right? Right. So the part C, find the domain and range. So let's look at the whole graph. We talked about the domain is all inputs or all x values in which the function is defined. Obviously, since it's breaking here, there is a vertical asymptote. It means it's not defined. So we have to jump that value. So we need to skip this x equal -1 for the domain, because the domain anyway is the x values, and the range is the y values, and we have these horizontal asymptotes. So if we go from the bottom to the top, the function goes towards the horizontal asymptote, but it does not jump or skip or whatever. It doesn't continue. It continues from here, and it looks like this one as well keeps going towards and in other courses we talk about limits and stuff, but for here you see that you need to exclude these values from domain and range. And usually for many, these are not an issue. It just if it's confusing to why brackets and parentheses, that's why we're going to use parentheses, because we're not including these values, we're excluding them. And we always do the negative infinity on the left. And positive infinity in intervals should be on the right, and these should have no brackets. All right. So let's this question just similar to the one we just did. It wants us just to graph the vertical asymptotes here. Let's see, it's not. Maybe I'll get this closer to me, and so we have a better drawing. All right, a little bit tilted, but that's better. So we go through the cases. It's a rational function. For these asymptotes, we need to check the degrees of the numerator and the denominator. The numerator is 1, the denominator is 1, so they're the same. So that's the case where we say if n equal m, then you have a horizontal asymptote, which comes from the front numbers, right? 6 divided by -2, which is -3. Then we always, of course, look at the denominator for the vertical asymptote, see if the denominator can be 0. And if you set the denominator to 0, then so for the vertical asymptote, we're gonna do the denominator to be 0, and -2x equal 9, and x equal -4.5. -9 divided by 2, 9 divided by -2. All right, so horizontal asymptote, it's a horizontal line, so that's a y equation. Y equal -3. So if this is 1, 2, and 3, something like this, but we usually, so if you ask why we each time we never did them that way, we have them something like this, like dashed lines, because they're not part of the function, all right? So -4, let's say 1, 2, 3, 4, and if this is 5, then it should be somewhere here. So this is the frame, all right? So y equal -3, and x equal -9/2. Yeah, you know, so to show that they're all the same. All right, so we're gonna stay in this video on the same topic, graph all vertical and horizontal asymptotes. Vertical, we're gonna go here again, x squared plus 2x minus 3. You set it to 0, so vertical asymptote. So maybe we'll just we'll go back to the video. And for these, we check if it factors or not, and if it factors, then it's easier just to use factoring. So the product of these two numbers is -3, and their sum is 2. Two numbers you multiply to get 3, right? So 1 and 3. So we need negative and positive, so it's just 1 and 3. And since we want this to be positive, that means the bigger number is positive. So a quick review there. So -1 plus 3, which we set to 0, and we get, so x plus 1 equals 0, and x plus 3 equals 0, and we get that. So it looks like we have two vertical asymptotes. We don't have one, we have two. So let's go ahead and graph them. And let's see. So x equal 1, if this is 1, And if x equal -3, let's say here. All right. So now what's left? Horizontal, it's asking for horizontal. Do we have horizontal? We're gonna check the degree of the numerator and the degree of the denominator. And if they're equal, then yes. So in this case, n and m are both equal. So we say n is equal to m and both are 2. So yes, we do have a horizontal asymptote there. And that will come from these front numbers. If there are no numbers there, then it's 1 and 1. So 1 kind of x squared and 1 x squared, 1 divided by 1. Vertical asymptote is horizontal asymptote is y equal 1. All right. So we go to 1. All right, so this is the kind of the frame. Set it up, and because you want to put the graph there, and you set these first, and after that it's just a matter of finding points. And when you use points, you want the question here is not to graph it, so we'll skip that part. But of course you will need some points here and some points. Let's show to the x-axis. You know, we need some to point. Let's say, so if sometimes with this pen it does not show on the screen when I talk about it. So you're gonna select some x values from here, so you catch the graph here, whether you know, and you will pick some points here, so you catch the graph there, and you would take some points here, so you have the graph on the right side of this vertical asymptote. Okay, so graph all asymptotes and of the following function, and it looks like let's just start with the easy one. Usually we look whether this is simplified or not, but it's already kind of simplified because two numbers. If we want to factor this out and simplify it, like the example with the whole there, two numbers you multiply get 1. Usually 1 and 1. So multiply to get -1 is just -1 and 1. -1 and 1, their sum is going to be 0. So this cannot be simplified to cancel out x plus 3. The vertical asymptote is going to come from x plus 3 equals 0, x equal -3. All right, so better drawing now, right? Next one, do we have a horizontal asymptote or do we have a slant asymptote? So we're going to check the degree. This is 2, and this is 1. So 2 is bigger than 1, that's first. It's not same. If they're the same, we saw that there is a horizontal one. They're not the same. But 2 actually is bigger than 1 by 1. If it's bigger than this degree by 1, then we have something we call a slant asymptote, right? A slant asymptote. So, or oblique, all right, some say oblique. All right, so that's what we have. How do we find this slant asymptote? We're going to need to do long division, synthetic division, but let's stick with one method. So for example, long division. When you do long division, if this is x squared minus 1, then of course in that case it factors. But if, let's say, x squared plus 1, then to do long division you need to have the terms n to show the terms. This is the x is missing, so you will make or create that is missing, which is 0x. So if you want to do long division, this is better way to start. This is x plus 3, so we'll go ahead and just do the long division. When we do long division in this type of example, we don't care about the remainder, right? So that's one thing, because the question comes to why it's not the square root, just division. And the slant is going to be here. Let's just put, it's going to show up there. We're divided by x plus 3. And so we're dividing this x squared plus 2x minus 1 by x plus 3. Which means we're going to divide the first by the first, which is x squared divided by x, which is simplifies to 1x. Then you will multiply this way, which means you're distributing. That's why I put parentheses to see that when you do that, it's not just x times x, but it's actually x times x plus 3, which is an x squared plus 3x. You distribute. When you do long division, you subtract down. All right, so long division, we subtract down. If you do synthetic division, you will add down. So two different things. And if it's confusing, just stick to one. Long division, it always works, so I use that one. So x squared minus x squared, that'll be 0. So 0x squared, which means gone from there. Then 2x. If you have multiple negatives, you want to watch how the operation is happening. So it's actually 2x. You write it down minus whatever is next there. Here in this case, it's just plus 3x. So negative and a positive will give me a negative. So negative x. Then it's negative 1 minus, here you can finish it as plus 0. Negative 1 minus 0, which is, or some just say bring down negative 1. All right, so we have a new thing to start with, right? A binomial there, so we'll start over by dividing negative x by x. So we'll do the first one again, divided by the first one. So negative x divided by x, which will give me negative 1. Then we're going to distribute again. Negative 1 times x is negative 1x. Negative 1 times 3 with negative 3. Then we subtract down. So this is negative 1x plus 1x out. So this is what I'm talking about if you have multiple negatives. So it's negative 1 minus negative 3, which is negative 1 plus 3, which is 2. I mentioned in this case, we don't care about remainder, but we care here about the answer here as y equal x minus 1. So this is not something new. You've done it before, you've seen it before. How do we graph this line? We're going to go to negative 1, and that's the y-intercept. The slope is 1, which means 1 over 1. So we'll go up 1 and over 1, and we'll get a second point. All right, except that line is not that good. All right, so All right, so again, if this question asks us to graph the function, then we want to pick up these values near the vertical asymptote so we know how it looks, right? So you'll use x as -4 in the function, you use -5 in the function until you start seeing how it looks. Then in between, you have 0, -1, -2 to use, and on this side, 2, 3, and 4. So you start using points until you see how it looks. And of course, once you see how it looks, then you will just use how it's approaching the asymptotes. All right, so this one is going for question, graph the rational function. Since it's a rational function, we're going to need to check whether it has asymptotes and what type of asymptotes it has. We're going to put them on the graph, then we're going to come up with some points and graph it. All right, so you see here we have x, but here we don't have x at all. So you can assume that there is 1 there, because something like this, if some value there, as let's say 1 power 0 is 1, for example. So just when doing this, just to show you that 0 degree is less than 1. And if it is less than 1, then the rule that you learned says that the horizontal asymptote is same as the x-axis. All right, so if the degree n is less than m, the way we did it, then you have a horizontal asymptote. So we're saying the degree there is less than the degree there. Then of course, the question is there is no degree. Sometimes it's confusing just to say there is no degree, just like the slope. Some would say, well, there is no slope. So this is another topic, but just to show that communication is kind of important too. If I have a vertical line, some will say, well, there is no slope. So what does that mean? Is the slope 0? No slope, right? Well, here the vertical line, its slope is undefined. So no slope could mean undefined or 0, but if it's 0, it's a whole different line. It's a horizontal line. So that's we're trying to clear up in the communication to make sure we're talking about the same thing and what we say we mean, and it's also understood. And we run into this when we talk about expressions and equations. So we often here, let's do, for example, then while we're factoring this equation, it's not an equation because it doesn't have an equal sign, so it's an expression. So stuff like this, it's still a language, right? Although some will say it's math, but no, it's another. It's language. It's communication, and we need to keep the communication kind of correct to make sure we're talking about the same thing. And when we want to explain it to others, they also understand what we're talking about. So we draw this, and I explained why the degree is lower. Then we need to look whether it has a vertical asymptote, which yes, from going here to x plus 2 and set it to 0, we're going to get that x equal to -2. Okay. Does it have a slant? No, because if it has horizontal, it's not going to have a slant, right? It won't have both. It won't have a horizontal and a slant, because for the slant, it needs this to be x squared. And if this is x squared, then it's not going to have a horizontal. So here we have some specific instructions, and plot at least 2 points on each piece of the graph, meaning a left side and right side of the vertical asymptote. You know, you can pick any points for x, but we want to stay close to it, so we get some points that maybe if I move this, you won't see it. So let's just say I'll draw it. So the frame, this is the frame. So when we pick points, we want to stay there. So we're going to pick some close points. Let's say -3, -4, and let's say -1 and 0. All right. So let's go to the right side of vertical asymptote here. And we're going to pick x equal -1. So if x equal -1, we're going to, becomes -1, right? So means the input is -1. So it's 2 over -1 plus 2, which is 2 over 1, which is 2. So the point is -1, 2. And if it's 0, I showed that before. If it's 0, now we just do this. That's 2 over 2, which is 1, right? Because sometimes you have some big thing and you start substituting and calculating. No, if it's 0, then it's eliminated. So if it's 0 is 1, if x equals 0, the answer is 2 over 2, which is 1. So 0, 1. So we can understand now, because this is an asymptote here, it's not going to cross it, it's going to go near it. Same thing here. So I can add more points, and they're going to show up something like this if you add more points, and they're going to give you the graph. So we do the same thing on the left. So let's try, the left side of the vertical asymptote here. So for example, if x equal -3, then x becomes -3, then 2 over -1, then it's -2. So -3, -2, -3, -2. Similarly, you know, I'm going to try more points, and I'm going to find something like this. So, but at least 2, so you need 2. If you're getting a good graph, then it's enough. If not, you do 3 just to be safe. And so if we graph this thing, it's going to be something like that. And when it says each piece of the graph, this is one piece and this is another, right? All right, so that's how we graph rational functions, and that's how we find these things in this case. And so it's good, so we move on. So similarly, we're going to do something here. So by now, you got a hang of it, right? You got the idea. I probably won't graph this one, so give it to you as exercise and ask you by now. So what is, let's do this as a discussion, and you're gonna try it. And of course, if you have questions, you can send them to me. So vertical asymptote, -x plus 2, 0, subtract the 2, x equal 2. we graph that here, right? Then do we have a slant? Do we have horizontal? We look at the degree. The degree is 1 and 1. They're equal. Anytime they're equal, we're taking these front numbers. And it's -4, right? So -4, that, and we say x equal to that, you know. So you will graph these and you will do the points just like we did in previous example. And you will graph. And if you have any questions, so I'll just put here, try it based on previous examples. Okay, so you can pause the video and try it and see. So I think that's it. So we'll do this is a new topic or a different topic. So we'll pick up this topic on another video. Just to make the videos, they're gonna be longer because I explain other things, relevant topics and objectives, and maybe scales, and so they're going to be a little bit longer, but we'll keep to keep the video not too long. We'll separate them into chunks, right, or into a few examples. All right. Thank you. Enjoy.